Hello friends, in the last video about compression, we have covered the theory part, and I have primarily emphasized on how the data will be processed on uncompressed data set and splittable compression and non-splittable compression. So I might not be able to produce all the scenarios practically, but when we use compression, typically when you compress the data, the file size can go down drastically. So let me show you what I'm talking about. If you see, there is a file called ziputdeck.txt.gz, and if I unzip it, and if you want to see the size of the file, the it is unzipped to ziputdeck.txt. So this file, which is of only 5 MB, is unzipped to file called ziput.deck.txt, and the size of the file is uh, 1.135 GB. So 1 GB, 135 MB, 411 KB, and 200 bytes. So it's approximately 1.1 GB. And if we do the row count on this file, if we copy this file to HDFS and if we run row count program on this file, as our split size is 256 MB, it will use around 4 mappers, and it will complete the job using 4 mappers. Now if I zip it, and see the size of the file, it is only 5 MB, and as this is lesser than our block size, it only one mapper will try to process the data. Whether use splittable compression or non-splittable compression, in this case, it doesn't matter. The splittable compression versus non-splittable compression comes into picture when after the compression, if the file size is larger than the block size. If you remember, using non-splittable compression, irrespective of the size of the file, even though it is larger than the block size, which is 128 MB in this case, it will still use only one mapper to process the entire data set. So performance wise, it will be very bad. To address that, you have to reduce the size of the file close to the block size, so that it leverages the data locality while processing the data. However, in this case, it doesn't matter whether you are using splittable compression or non-splittable compression. If you don't understand that, go back to the compression theory video in the YouTube channel, and then you will be able to understand it. Let me show you where it is. So this is my channel, and I am clicking on this, and then if you go to my playlist, there is a playlist for performance tuning which I have uploaded recently, and if you click on this, there is a playlist for compression theory. So if you have any doubts about how compression works before understanding the further practical session, you just have to go through this 16-minute video. Okay, being said that, splittable compression or non-splittable compression doesn't matter here. um, uh, uh, After compressing this 1 GB file, it is only 5 MB, and if we run the row count program on this, it will only use one mapper. Let me show you I have already copied the file to HDFS. Let me show you that. So this is the file I am talking about, which is already copied and it is only 5 MB. Now let me run the row count program. So I am running the program and it is using only one mapper because the size of the file is only 5 MB, which is much lesser than one block size. So that is the reason why it is only using one mapper. So in this case, our cluster is idle. Our cluster capacity is 17. I am going to the cluster and I am trying to watch the job. In this case, there is only one job that is running and it is only taking one mapper. And let me show you the what is happening on my cluster. So 8088 and this is the resource manager IP which you need to use in this place if you are using a different cluster, and this is the port number for the resource manager if you are using yarn. And if you see there is only one running job, you can click on this and see that there is only one running job. Even though capacity is 17, we are using only one mapper to process the data. So we are underutilizing the resources in this case, and it will take quite some time to get the row count. Okay, let it complete, and then we will talk about how to tune this how to tune this scenario um, to increase the speed of our of processing the data to do the row count. So it is completed. We have processed um, 1 GB of data after compression with one mapper, and then we will compare with we will see how we can tune the scenario where you use you underutilize your cluster to process the compressed data. Okay, so first thing what you need to do is instead of uh, compression is key because it reduces the storage footprint. But at the same time, as we have seen, if you do not design the compression properly, your cluster will be underutilized and your jobs will unnecessarily run slow. So to address this issue, you should design your approach in such a way that data is compressed, but still it leverages the resources completely to process the data as part of your MapReduce application runs. Okay, so what I have done is I have created a directory called zip.dex, and uh, instead of combining all the files and then zip, what I have done is I have splitted the data into 10 different files and then I have zipped. So in this case, um, uh, this one is nothing but a uh, combination of all these files. If you unzip one of the files here, and the size is 113 MB, which is 1/10 of uh, the larger file which we have processed earlier. Let me show you. So this one, it is 1.135 GB and this is 113.5 MB, 1/10 of the file. So what I have done is I just splitted the files before actually zipping it. So you have to design your approach in such a way that you compress the files under or close to your block size, and then you can actually use more mappers to process the data. So you need to keep in mind all the stuff which we have discussed so far before designing the strategy. But the main idea which I am trying to communicate is how you can use compression in conjunction with splitting the data into smaller data sets so that you can efficiently utilize your cluster by providing more computing power to process the data. Now let us see what will happen when we run our MapReduce application on this data set. I have already copied this one. You can look at here. There's a directory called zipdex, and if you see, it has 10 files. Now if I run the MapReduce program, so I'm running the MapReduce program, the same row count program on this directory, zipdex, and if you see, it is using 10 mappers rather than one mapper. So you are using resources more effectively on the compressed data set, and it should run faster than the previous job, which used only one mapper to process 1 GB of data, which is compressed to 5 MB. In this case, each file is only 550 KB, but as you already know, our data set is a deck of cards, and as the data is repeated, as there are only 52 unique records and it is repeated many times in the data set, the compression rate is very high. So that's the reason why a 100 MB file is compressed to 550 KB, but in reality it will not be the case. You might get compression rate between 3x to 20x depending upon the duplicates in the data, and but still you can use this idea to design your problem in such a way that data is compressed while storing, and then it uses ideal number of resources while processing. So for that you have to split the data sets and then compress rather than clubbing the data set and compressing it. And this is more relevant when you use splittable compression, non-splittable compression format. um, uh, you have to do this. You have to copy data into files of size close to your block size, and then you will be able to use as many mappers as you want. If you use non-splittable format, and if the file size is much larger than your block size, then the performance of your MapReduce applications on that dataset will be very bad. So the execution is completed. Let us compare the results. Okay, the first file system counters is same, and the main difference is launched map tasks for the first one is only 1, whereas for second one it is 10. And then total time spent by all maps, if you see, is higher in this case because we are using 10 mappers instead of one mapper. So it is using more resources here, but as our cluster is not very busy, it is okay. It is not a problem because the execution time will be much faster. So those two are the main things. So you have to carefully understand the side effects of the compression, and if you design it properly, you can actually reduce the storage footprint significantly, and also you can provide necessary computing power to process your data. So now let us see from the program point of view what changes we made. We haven't made any changes, so especially to process the data. If you see, I ran this program row count, and I use the same program for both getting the count on uncompressed data as well as on compressed data. So in this case, if you if you are using standard compression algorithms which are supported by Hadoop out of the box, as long as the file that is zipped is of supported format like text input format, it can process the data without making any changes to the code. So so from code point of view, we haven't made any changes to see how we can process the compressed data. Only thing is, the way you design your data sets is the key when you are using compression to reduce the storage footprint on your cluster. I hope you enjoy the session. Thank you.